1, linear equations. It should be a fairly easy review of Algebra 1. We're going to check solutions of equations, solve linear equations in standard form, and then in non-standard form. So let's define an equation is a statement that equates two algebraic expressions. Okay, so you're going to have an equal sign, then there's going to be some expression over here and some expression over here. Remember, an expression, it can have numbers, it can have variables, it can just be a number, or it can be an expression, but an equal sign in the middle and two expressions on both sides. So a linear equation is one that can be written in standard form. Standard form would be a number a and then x and then b equals a c. So something like that would be 3x plus 4 equals 12, or negative 2x minus 5 equals negative 16. Those are types of standard forms. Solving an equation, so when I say solve an equation involving a variable, means find all the values of that variable for which the equation, I spelled that wrong, for which the equation is true. So find the value of the variable that makes both sides of the equal sign the same thing. Okay, so basically means find x. Those values that make the equation true are called solutions. Solutions satisfy the equation. So that's what I was saying. You find out the number, you find out what x is, and that means when you plug in 7 on both sides, those sides are going to be equal. So let's check solutions. Okay, so it says determine whether x equals negative 3 is a solution of this equation. So here's our original equation. Our next step is to substitute negative 3 for x. So anywhere we see an x, we put a negative 3. So it's negative 3 times x, so I'm going to sub in a negative 3. And it says minus 5 equals 4 times x, so I'm going to sub in a negative 3 plus 16, and then I'm going to solve. Following order of operations, I need to do multiplication first. Now remember, we're just checking both sides of the equal sign, and we're going to get down to a number equals another number, and we want to see if that's the same thing. If it's the same thing, then negative 3 is a solution. So I'm not doing anything across the line here. I'm just simplifying this side. So negative 3 times negative 3 would be a positive 9. And I'm going to simplify this side. 4 times negative 3 would be negative 12. And I'm trying to figure out, are these equal? So I'm going to put a question sign over the equal sign. I don't know yet. 9 minus 5 would be 4. And negative 12 plus 16 would also be 4. So yes, 4 does equal 4. When this happens, when both sides are equal, then we can say that x equals negative 3 is a solution. Okay, so what would happen if we checked negative 2? So we substituted, we simplified, and then now let's do that with negative 2. I'm going to do it over here so there's more room. So I plug in negative 2 wherever I see an x. I'm trying to decide, are they equal? And I'm going to simplify both sides. Okay, and you should have found out that it's not a solution. When you plug in negative 2, then this side is 1 and this side is 8, and those aren't equal. So negative 2 is not a solution, but negative 3 was. And for the sake of time, I'm not going to go over this. Again, you just plug in 0 on both sides, simplify one side and simplify the other, and find out if they're equal. So I believe that you would find out that this is not a solution. Negative 1 is not a solution. Down here, when you plug in negative 4, it's not a solution. But when you plug in 12, it is a solution. Something that I want you to be aware of is if I start with this original equation, 4x minus x equals 8, an equivalent equation would be 3x equals 8. So combining like terms, it's equivalent. It hasn't changed the equation at all. It's just simplifying it. So if you can simplify it without changing the value of x, by either combining like terms or following those properties that we talked about from chapter 1, where you can add on both sides of the equal sign or subtract or multiply or divide as long as you're doing the same number, right? The addition property of equality is what they called it, or multiplication property of equality. Or use some of those inverse or identity properties. If you can use those properties or combining like terms, you're just getting an equivalent equation. It's not changing the value of x at all. So we're going to use that idea to help us solve linear equation in standard form. So when we solve, we need to get x's on one side and values or numbers on the other side. So I'm going to start by trying to move this -12 over to the right side, because I want to move it away from the x values. So I'm going to use the addition property of equality that says you can add the same number on both sides and it not change the value of the equation. They're equivalent still. The reason I'm adding 12 to both sides is because I know that this will be an inverse of -12. And because I'm using the inverse, -12 plus 12 is 0. So I have 4x plus 0, which I'm not going to write, equals 0 plus 12 is 12. Okay, so I got rid of the numbers over here by using an inverse. So I want to use the same, or I want to use an inverse again, same idea, to get rid of the 4 times 4. Well, the inverse of that would be taking this times 1/4. And a lot of times when we take things times a fraction, it's the same as dividing. So timesing 1/4 is the same as dividing by 4. So I'm going to use division on both sides in order to make sure that the inverse will make this a 1. It ones out. A lot of times you say cancel, but it really turns into a 1. So we have a 1x, which we don't write the 1, equals 12 divided by 4 is 3. Now that I have x on one side and numbers on the other, I have my answer. And as always, we can check the solution like we did in the slides before. Okay, that was in standard form, but sometimes we have non-standard form and they look a little funky. So I'm sure that you're good at doing standard form, and non-standard is the one that we need to work on. So in this equation, again, we need y on one side and numbers on the other. It doesn't matter which side or the other. But I need to get rid of these parentheses, okay? So let's distribute. Use that distribution property. 6 times y would be 6y. 6 times -1 would be a -6. And everything else stays the same so far. All right, so I have y's on both sides and I have numbers on both sides. Deciding which way to move your y's, I always look at where could I move the y so that it stays positive. For instance, I could move the y's over to the right side, but that would mean I'd have to subtract 6y. Well, if I subtract 6y, then I'm going to get -4y over here, and I don't really want a negative. I could do it and it would work out, but I'd prefer not to use negatives. So let's move the y's to the left side, because I know that if I subtract 2y here and on the left side, that's inversing, so that's adding up to 0, right? A positive 2y and a negative 2y are adding up to 0. So there's only a -3 on the right side. And when I subtracted 2y on the left, I can only subtract it from its like terms. I'm not subtracting it from the -6, but I am subtracting it from the 6y because they have the same variable raised to the same power. So 6 take away 2 would be 4y's, and then drop down my -6. So notice, when I subtracted 2y, I've only done it twice, once per each side. It's not like I'm subtracting 2y everywhere. Once on each side. So a little closer, I got rid of the y's on the right, but now I need to move this -6 over here. Okay, because we decided we want y on the left side, now we need numbers on the right. So to cancel out a -6, the inverse would be a +6. So I want to add 6 here, and if I do it on one side, addition property of equality says I have to do it on the other in order for these to be equivalent. All right, so my -6 and +6, they zero out. They add up to be 0, so I don't need to write that. And then -3 plus 6 would be a +3. The last step I need to do is get rid of this times 4. Well, to undo a multiplication by 4, I want to divide by 4. If I do it on one side of the equal sign, I have to do it on the other. The 4's cancel, or 1 out, and I get y equals 3/4. It's okay to have a fraction. I'd prefer you leave it as a fraction rather than a decimal. And if you're unsure you did it correctly, plug it back in for y on both sides. Wherever you see a y, plug in 3/4 and see if both sides of the equal sign are the same number after you simplify. Okay, over here, same type of deal, non-standard form. Go ahead and solve for x. All right, hopefully after you solved it, you should have gotten 5/2, which is the same as 15/6 simplified. And remember, a negative divided by a negative would be a positive. So I divided each of these by 3, and that's how I got 5/2, or 5/2. My first step was to subtract 10. The other way that you could have done it, if you didn't want a negative x, you could have added 6x to both sides. Now, if you do that, you got to be careful. You can't combine these. They're not like terms. So it's still a -5 and then plus 6x equals a positive 10 over here. And now you have to move the 5 over here because x is now on the right, so we want to move all the numbers away. So if you add 5, those would cancel, and you'd get 6x equals 15. And then divide by 6, of course, and you get x equals 5/2. Something that I want you to be aware of, let me do it one more time. A lot of the time students will add 5, which is fine, you can do that. And this cancels. Well, what's over here if that cancels? There's got to be something. You have to put something. You can't just get rid of the equal. I mean, there's got to be two things on both sides of the equal sign. So the thing over here after that cancels is 0. 10 plus 5 is 15. Drop down your minus 6x. Now, it doesn't matter what you move over here, but you need numbers on one side and variables on the other. So what I would do in this situation would be to add 6x to both sides. That way my variable is positive and I get 6x equals 15 after these cancel. Okay, so see how there's like 3 different ways of doing it, but we all should get the same answer of 5/2. Okay, what happens if your linear equation has fractions? Well, before you could do anything, you need a common denominator, right? And the common denominator between 18 and 4, if you don't already know, you'd have to list out all the multiples of 18. So it'd go 18, 36, 4, 8, 12, 16, 20, 24. I'm still not at a common one yet. 28, 32, 36 would be the common multiple. So that'd be the denominator that we need. And you could go ahead and do that. That's fine, where you'd have to take this fraction times 2 and this fraction times 9 and then this times 36. That's perfectly fine, but I'm going to teach you a new way, and it's to multiply each side by that 36, the least common denominator. Okay, so we found the denominator that we need. What we're going to do is multiply both sides of the equal sign by 36. So I'm going to put this whole thing in parentheses, and this guy in parentheses. And I'm going to put my line down the middle of the equal sign. Now what's happening when I do this is I'm going to get rid of all my fractions. I don't particularly like working with fractions, so if I multiply each side by the 36, fractions will disappear, and I don't have to worry about a common denominator or any of that stuff. So what I want you to think about is 36 as a fraction is 36/1. So when you take it times this first fraction, of x over 18. What you're doing is you're taking 36 in the top and 18 in the bottom. You're essentially dividing, okay? Because when I multiply this fraction, just as a little sidebar, don't write this, I'd get 36x over 18 if I multiplied these two fractions, the two top numbers and the two bottom numbers. So 36 over 18 would just simplify to 2x. Okay, so think about that. So I've gotten rid of the fractions. When I multiply these, I get 36 divided by 18, which is 2, and then the x is being multiplied by it. The next one, when I distribute, and a little sidebar off to over here, I have 36 times 3x over 4 times 1. Okay, so what you're doing is you're multiplying by the top number and then dividing by the bottom number. So 36 times 3 is 108. So you have 108x over 4. 108 divided by 4 is 27. So I have a 27x here. Okay, so when we multiply each side by 36 and we distribute, simplifying means you multiply the top numbers, 36 times 1, divide by the bottom. 36 times 3 divided by 4 is 27, and drop down my addition sign. And then equal sign, 2 times 36. For the other side of that equation is 72. Look, no more fractions. So now this just becomes a problem where I can combine like terms. 2x and 27x means 29x equals 72. And divide by 29. And I get 72 over 29 for my final answer. So I can't simplify this fraction. 29 is a prime number, so there's nothing I can divide the top and bottom by. So I know that's a new concept, multiplying both sides by the LCD. So let's try one more. The LCD, now I need to figure out between 15 and 10. So I can list all the multiples of 15 and list all the multiples of 10 until I find a match. And I know that my LCD is 30. So I'm going to multiply both sides by 30. I'm just going to stick them in parentheses. Draw my line down. And when I do this, remember I am distributing the 30 to both items. 30 times z, that's easy. That's just 30z. Notice how I put a line through my z so it doesn't look like a 2. I'm going to drop down my plus sign. 30 times 1 over 15. Remember, you're multiplying 30 times the top. So 30 times 1 is 30, and then dividing it by the bottom. So 30 divided by 15 is 2, and there's not a z with it. And then over here, I have negative 3 over 10 times 30. So I'm going to multiply the top. 30 times 3 is 90. Divided by 10 would be 9, and there's a negative sign there, so negative 9. Now I just simply solve like I would any other equation now that I don't have fractions. So I'm going to subtract 2 so that those cancel. And I have 30z over here. Negative 9 minus 2 would be negative 11. And divide by 30 so that those cancel. And z equals negative 11 over 30 for my final answer. Sometimes our equations are involving decimals, so again, there's two different ways to do it. You can just leave them as decimals and solve just like you normally would. We have to distribute here to get rid of our parentheses. So 0.09 times 5,000 would give you 450. And then 0.09 times negative x would be negative 0.09x. And then drop down your 0.12x. Combine like terms. Combine your x's. So 0.12 and then minus 0.09 would be 0.03x. You still have the positive 450 equals 513. Subtract the 450 because we want to move it away from the x. All right, I have my x term on the left, so move the numbers over here. So 513 minus 450 would be 63. And now I need to divide by my decimal, 0.03 on both sides. And I get x equals 2,100. Okay, so everything stays the same except now you're, instead of typing whole numbers into your calculator, you're typing in decimals. The other way of doing it, which you may or may not like, is to multiply, or I'm just going to say move the decimal, the number of place values that your smallest decimal is to get a whole number. Okay, so what does that mean? Sorry, I kind of ran out of room here. Okay, so same problem, different way of solving it. I want you to look at all your decimals. I have a 0.12 and a 0.09. If I wanted to make these whole numbers, I would have to move the decimal one 2 place values. Okay, so what I'm going to do is I'm going to move the decimal 2 place values, but I have to do that for every number in this problem so that it's an equivalent equation. It's the same thing as multiplying everything times 100, because taking this times 100 would end up moving the decimal 2 places backwards. Okay, so if I did that, my new equation would be 12x plus 9 times, now it's not 5,000, I have to move it back 2 more places, so it's 500,000 minus x equals, again, move it back 2 places, so I get 51,300. Now that I have no more decimals, again, I'm going to solve the same way by distributing. So I get 4,500,000 minus 9x equals 51,300 plus 12x. So combine my x terms. I get 3x. And subtract the 4 million. Oops,